Okay, so modeling with functions. Okay, first, it would be good if we defined what a function was. Okay, so let's go ahead and write this down. This is one of your vocabulary words, so you might want to highlight it. Okay, so a function is a relation in which every domain value, and usually domain values not all the time, but usually are represented by x's. So where every x is paired with exactly one range value or one y value. Okay. All right, so one thing that is important for us to make note of about functions is that the x values, if it's a function, the x values are not being repeated. So we kind of looked at some examples of this, right, after the warm-up, where we looked at the table, and if it had the same x value twice in the table, it was not a function, right? We also looked at the mapping, right? If in the mapping it had two arrows coming out of the same x value, that meant the x value was repeated, and so it's not a function. We also looked at a graph, right? It's not a function if in the graph we can draw a vertical line and it passes through two values, because that means those 2 points have the same x value, okay? So that those are not functions, okay? So in functions, x values are not repeated, okay? Also, like we talked about earlier, all functions will pass the vertical line test. Which means they only pass through one point. They pass through more than one point, they're not going to be functions. You guys need some time catching up there? Yeah. Okay. All right. So next, each function has something called an independent variable and a dependent variable. So we're going to go ahead and take a look at what each of those things are. Okay, so we're going to define each of these. These are also vocabulary words, so you might want to highlight them. Okay, so an independent variable is the input of a function and its value determines the output. Okay, we also have something called a dependent variable. This is another vocabulary word. And the dependent variable is the output of a function. And its value depends on the input. Okay, so let me give you guys an example of this. Okay, I know like most of us, we send things by email nowadays, but back in the old days, we used to mail things. All right, and we used to sometimes go to the post office to mail those things. And when you go to the post office, You have to buy a stamp, because if you don't buy a stamp or you don't pay for postage, they're not going to mail your letter, right? Okay. So, yeah, I know, long story, right? Okay, so here's an example. The number of letters I send determines the amount of postage, or the total cost of the postage. Forgot that word there. Okay, so the number of letters is what we would call the independent variable. Okay, so the independent variable is the one where when I change it, it's going to affect the other, right? So if I only mail 2 letters, the postage is going to be a certain price. But if I mail more, then the cost is going to go up, right? If I mail less, then the cost is going to go down. Does that make sense? So the number of letters is independent. Okay, the cost of the postage is going to be dependent. It depends. This one depends on the first. Does that make sense? Bless you. So, like, I go to the post office. The postal lady doesn't tell me how much I pay first. She asks me how many letters I'm mailing. Then she tells me how much I pay, right? So I have to know this one in order to figure out the second one. Okay? Bless you. Okay, so last we're going to talk about function notation before we move on to all of our examples on the green sheet. Okay? So, function notation. What is function notation? Well, normally we write equations with variables, right? And sometimes we can have 2 different variables in one equation, right? Like if the number of letters is changing and the cost of postage is also changing, then I might have 2 different variables in that equation. Okay? But when I'm writing something in function notation, I want to put everything kind of like into one variable. Okay? So typically this happens where x is the input, not always x, but usually x is the input, okay, and y is the output. Okay, we would say that x is the independent and y is the dependent variable. So here's how we would write something in function notation. If, let's say, I had this regular equation, y equals 2x plus 1. Okay, this is like a standard equation. All right. In function notation, it would look like this. F of x equals 2x plus 1. Okay. So I'm changing my dependent variable to f of x, or f of whatever the independent variable is. Okay, so this is here function notation. Now I know it's kind of weird looking, but how many of you guys have seen this notation before? Like, or been exposed to it? Okay. Alright. So, when we see this, what we say when we see this is we say f of x. That's what we say. Okay? You guys can't see it. Hold on, let me fix it really quick. Okay. So we say f of x when we see that. Okay? Now, it doesn't mean f times x. That's not what it means. F of x is representing a quantity, like an unknown number. So this whole thing is taking the place of this variable. So really this whole thing represents one number. Okay? What students often think is this means 2 things multiplying together. That's not what it means. This whole thing is just another type of variable, you could say. Because it's going in the place of y. Okay? So the f of x, this whole thing, is what we would call your dependent variable. And then just the x by itself is considered the independent variable. Okay, so let's take a look at some of these example problems we have here. Okay, so the first problem set, it wants us to identify the dependent and independent variable in each situation. So number 1 says the cost of a dozen eggs depends on the size of the eggs. So the cost is dependent, and that depends on the size, right? Okay, like if I go to the grocery store, if I buy medium eggs, they're a different price than if I buy large eggs or extra large, right? They charge me more depending on if I buy the bigger ones. Does that make sense? Okay, so the cost is depending on the size. All right, now let's look at the next example. Allie works in a shop for $18 per hour. Okay, when she goes to work, she gets a paycheck, right? Her pay depends on what? The hours she works, right? The $18, her rate, that doesn't change. Like she's making $18 per hour every day, right? But the amount of hours she works, that might change. That's variable, okay? So her pay, or her total check, depends on the number of hours that she's working. Okay, now let's look at the very last one. 5 pounds of apples cost $7.45. So what's dependent here? The cost. And what does the cost depend on? The weight or the number of pounds, right? They're selling these apples by the pound apparently, so it would be the number of pounds. You could also put weight there. Okay? That would be fine too. Okay? So does that make sense on those ones? Okay, so now let's take a look at the next problem set. It says for each situation, write a function as a standard equation and in function notation. Okay, so let's take a look at number 4. Keisha will mow grass for $8 per hour. Okay, as a standard equation, her pay she would get is going to equal $8 per hour, right? Something like that. Her pay is variable. Her number of hours is variable also. You could use other variables than x and y. You could use like p equals 8h if it makes more sense to you that way. Okay? But when we write this as a function, what did we do in our examples we did in our notes just a little bit ago? What did we replace the y with? F of x. So my function is going to be f of x equals 8x. I'm just replacing the dependent variable with f of x. Okay? Okay, so let's look at the next one, number 5. Okay, oranges are on sale for $1.59 a pound. So the cost of the oranges is equaling what? 159 times the number of pounds, so times x, right? You could do C equals 159P if you wanted to use other letters, okay? But when I go to write this in function notation, what am I going to be replacing y with? F of x. And if I use f of x, then I'm going to make sure that this variable right here is also an x, okay? Okay, so let's look at the last couple problems. Okay. For the next one, it says, for each situation, identify the dependent and independent variables. Write a function in function notation and use the function to solve the problem. Okay, so the first problem. A plumber charges $70 per hour plus $40 for the call. So 70 per hour plus 40, right? What does he charge for 4 hours of work? Okay. So first of all, what's the dependent variable here? The cost or the charge, okay? I'll use the word charge since that's what they used in the problem. Okay, now, what's independent? Yeah, the number of hours. Okay, so our function, we're going to write it in function notation, is going to be f of x equals, well, how much is he charging per hour? 70. So 70 times x. X is the number of hours, right? Okay, plus what? 40. Okay, now, our solution is going to be the answer to this question, what does he charge for 4 hours of work? Okay, so to solve this, what I'm going to do is I'm going to replace my number of hours with 4. So everywhere I see an x, I'm going to put a 4. Now, I know this is kind of funky because you're like, what do I do with this f of 4 now, right? You just leave it like that, okay? So, the function evaluated for 4 hours is going to be 280, and I'm just going to simplify this side over here. 280 plus 40. And what is 280 plus 40?
320.
Okay. So, if you were to answer this question with a complete sentence, what would you say your answer is?
The solution to this problem is 320.
Okay, but I ask you, what does he charge for 4 hours of work? Answer me.
$320.
He charges $320, right? Okay, so okay, now some boys and girls see this part and they start to like think that they need to divide by 4 at the end to get rid of the 4, or they need to do something with that 4. Remember, this does not mean f times 4. It's just saying when there are 4 hours in this function, the total amount's 320. You can leave it like this at the end. You don't need to get rid of the 4, you just leave it alone. Okay? Focus. Thank you. Okay, let's go ahead and take a look at the last one, which is number 7. Okay? So, number 7, a sanitation company charges $4 per bag of garbage pickup plus $10 weekly fee. The restaurant has 14 bags of garbage. What will the sanitation company charge the restaurant? Okay, first of all, what's important information in here? $4 per bag. What else? $10 weekly fee. What else? Yeah, the restaurant has 14 bags of garbage, right? Okay, let's identify the dependent variable. What's the dependent variable?
The charge.
Yeah, the charge, right? Or the cost. You can write either one, it's okay. All right, what's independent though?
The bags of trash.
Yeah, the amount of trash, and they're charging per what? Bags. So it's the number of bags of trash, right? Because they're not like charging by pound or by box, they're charging by bag. Okay? All right. So now let's write a function. F of x equals, okay, $4 per bag. So our charge equals $4 times the number of bags. Let's let that be x, plus our $10 weekly fee. Does that make sense how we got that? Okay. Now let's solve it. So in our solution, how many bags did they want to know about?
14.
So we're going to evaluate this function for 14 bags. So the function at 14 bags is going to be 4 times 14 plus 10. Well, what is 4 times 14? 56. And what is 56 plus 10?
66.
66, right? Okay, so f of 14, the function for 14 bags, equals $66, right? So now, let's answer the question. What will the sanitation company charge the restaurant?
$66.
Yeah, they will charge $66. Okay. All right, any questions? All right,